Hello everyone and welcome to this training. My name is Christine Knotke and I'm a clinical data specialist at the Personalized Health Informatics group of SIB. The topic of today's training is how to create concepts for the SPHN dataset. So let us start with the question, why do we need the SPHN dataset? Today there are many data collections, such as clinical trials, registries, cohorts, or data collections for specific research projects. And for each of those collections, there's an individual specification for the data. So when we take the example of gender for clinical trial, female gender has been encoded with the abbreviation FEM. For registry B, female gender is encoded as 2, but we see here as well that for the research project A, we have the encoding of weiblich, which is German for female gender, as 1. And this results in a high effort to integrate such data for reuse. When we integrate it, for example, for a national data stream or other projects, we need to do a lot of mappings and a lot of manual work is involved. So what do we wish for the future? Tomorrow, we want to collect data only once with agreed standards and reuse them for different research questions. This would enable true data-driven science and avoid all those many extra steps we currently have to do. With a data specification, such as the dataset, and connected terminology standards, for example, SNOMED CT or LOINC, we could agree once on the codes that are used. For example, for feminine gender, the SNOMED CT code you see here. So let's take a look at the dataset. How does the dataset is designed? The dataset defines concepts such as respiratory rate. And these concepts are described with their meaning. And these are concepts that are shareable in the SPHN network. For each concept, there is a description, a meaning binding to a SNOMED CT code or a LOINC code if that's available. And the concepts consist of so-called composed offs. In this example, the composed offs are rate, determination date time, and data determination method. For the last one, the data determination method, you see that there's a value set defined. And for this value set, we use controlled vocabulary wherever it's possible. And in this example, it consists of SNOMED CT codes. As a summary, the dataset contains meaning binding for concepts. This is helpful, especially for analytics and when it comes to using the knowledge that's built in those terminologies. It contains general and contextualized descriptions and coded value sets. The dataset is developed by the Data Coordination Center together with the Semantic Working Group and project partners. It's released 1 or 2 times per year, and it is published by the DCC on the SPHN website as an Excel file. As the creation of the dataset is a collaborative endeavor, we have set ourselves some guiding principles for concept design, and I would like to explain those principles alongside an example. Overall, it is a compositional concept approach. Concepts can be combined, similar as we can do it with Lego blocks. And the principles are conceptualization, concept reuse, concise and domain independent development of concepts. We use controlled vocabulary for value sets, but also for concepts. And the last one is the semantic inheritance as a very important principle. So let's start with the conceptualization. The starting point for conceptualization is often looking at the variables of a project. That could be, for example, as we see here, head circumference in a pediatrics form where the head circumference of children are collected. Or in a lifestyle cohort, it can be waist and hip circumference that is recorded. Identifying the concepts we could say that head circumference is a concept, waist circumference is a concept, and so on. And we see that every item has defining parts, such as the value, the unit, and the measurement date time. This is what we call conceptualization. The second principle is concept reuse. We always encourage to look at the SPHN dataset. What existing concepts are there already, and can we reuse them? So what we find here is that value and unit is defined already in the so-called concept quantity, and we can reuse it to define our new concepts of head circumference measure and waist circumference measure. So here we can see what that means with the example of head circumference. The concept of head circumference will have a composed of quantity instead of value and unit separately. And the reuse of the concept is made visible in the dataset in a way that we state that quantity is in column type for the head circumference quantity. In other words, the head circumference quantity is a quantity which is composed of value unit and even the comparator if it is needed. Now I would like to ask you to take a seat in the helicopter. From above the mountains, you will see that there's not just one mountain, not only one project, but several projects we want to serve with the data. So we can see that head circumference, waist circumference, hip circumference are all circumference measures. And there might be projects that are even interested in other circumference measures of the body, such as neck circumference or upper arm circumference. Making this step, we create the overall concept circumference measure instead of the single concepts we have seen before. And this general concept circumference measure is composed of the body side, the circumference that was measured, so the value and unit, which is the quantity, and the measurement date time. That way we are concise. We have now one concept instead of three or even more. And you see here as well that for body side, we can apply the principle of reuse again. In the dataset, we find that body side is defined already in a way that codes of the SNOMED CT structure or SNOMED CT hierarchy body structure is allowed to be used for this kind of value set. So here you can see the value set specification of the body side code. Looking at the SNOMED CT hierarchy on the right side, we see that head structure is actually a descendant of the higher concept body structure in the SNOMED CT hierarchy. That allows us to define the value set for our circumference measure concept. We have already a guiding border to design it, and all the SNOMED CT codes you see here we have chosen now for this value set are descendants of the higher SNOMED CT concept body structure. But not only the value sets are represented with controlled vocabulary, but also for the concepts itself, we use that principle. Here you can see the circumference measure concept, and we create a meaning binding to the SNOMED CT concept circumference measure. This so-called meaning binding supports the machine readable and semantic interoperability of SNOMED encoded datasets. The last guiding principle I would like to highlight is the so-called semantic inheritance, and here we move to another example. What does it mean, semantic inheritance? In the SPHN dataset, we have, for example, several kinds of diagnosis concepts: nursing diagnosis, FOPH diagnosis, ICDO diagnosis. All of them have a certain set of attributes in common. And for the diagnosis, the basic set is code, record, datetime, and coding datetime. This is why we introduced a general concept diagnosis, and the specific diagnosis concepts such as nursing diagnosis, FOPH diagnosis inherit this basic set of attributes. Here you can see how this is actually stated in the SPHN dataset. For FOPH diagnosis, code, record, datetime, and coding datetime are inherited. And in addition, FOPH diagnosis has a composed of rank, which is really specific for this kind of diagnosis, and the other kinds of diagnosis like nursing diagnosis would not have this additional attribute, but might have others. This brings me to the end of this training. If you want to learn more and you are interested in how to use the SPHN concepts, you can find here links for further training videos. And in those training videos, we explain, for example, how the concepts can be implemented to serve instantiation of health data, as well as data integration and analysis. So thank you very much for your attention. I hope the training helps you to design the concepts you need for your projects.